So, good evening, or afternoon, or morning, even, depending on where you are. And welcome back to our 23rd Ode on the Code already. Um, Today we have two awesome speakers for you, and things are going to be a little bit different, mostly because the planning is a little bit different, but more on that in a second. Um, our first talk is going to be by Michiel. He's going to talk about continuous delivery, about a real life project they did with 4 development teams. And they had this massive monolithic application which had like bi-weekly deployments. There was a lot of problems with that, errors they ran into, and how they changed it all and really fixed it up so they could do 30 automated deployments per day while also reducing the overhead and increasing the quality. So if you're just getting started, or even if you already know a lot about continuous deployments, this is definitely the talk for you. And after that we have Louise, who's going to talk about living with a perfectionist mind. And it's going to be a little bit different because this is not purely about programming, but Louise, lives and deals with having a perfectionist mind, and is going to tell us everything we need to know on how to deal with it. It's going to tell us like what are some traits you might have or might see yourself doing. Like, do you have a perfectionist mind? Um, and how to deal with all of that. So first we have Michiel, with a talk for about an hour, um, a small 10-minute break, and then Louise will be joining us for the second talk. So, hello, Michiel.
Hi, how you doing?
Doing really well. I'm really excited about both of your talks. Definitely about the continuous delivery talk as well. It's something I'm just getting started with, so I'm hoping I'll be learning a lot from you tonight. And yeah, it's great. How are you today?
I'm very good, thank you. Enjoying the weather. Well, not right now, obviously, but in general today I've been enjoying the weather.
It was good until the rain
Yeah.
kicked in. Yeah, definitely. Yeah, there were some people running outside. Yeah, that's they didn't see that coming. Um, without much further ado, good luck with your talk, and I'll talk to you in an hour or something.
Okay, great. Well, hello everyone. Good evening. My name is Michiel Rook. I'm a freelance consultant based here in the Netherlands. And tonight I'm going to talk to you for about 40-ish minutes, 45, depending on how we go and the questions that you'll have, about a project that I did a few years ago. Now, if you want to reach out to me, I've been promised that the chat will be followed for me. If there are any questions, we'll deal with those after the talk. And if you want to reach out later, on screen in my presentation, there's the Twitter handle that you can reach out to and ask me questions later, or give me feedback, or tell me to shut up. That's all of the above are good options. So real world continuous delivery. Why real world? Well, I'll talk about the theory a little bit and about the books behind the theory, but theory only gets interesting when it's put into practice, okay? When we start to implement things. That's when we actually learn how the theory that looks great on paper behaves in realistic scenarios in the real world. And it doesn't always work, of course. And that's what I'm about to tell you, at least one instance. So the project I'm going to be talking about, the company I'm going to be talking about, this is not a talk that is, I did this, it worked, so you should, right? This talk is about how we did things, the things we learned from that, and maybe a takeaway or two for you to use in your own company, your own problem, your own product, your own project. So let's get started. The talk I'm going to give you today is about a large semi-government organization in the Netherlands. I cannot disclose the name, but it is a large organization, well known, with a lot of competition inside Europe and outside of Europe. So I was part of this organization from late 2017 to late 2018. So it's a couple years ago. But this is an interesting project nonetheless, even though it's a little bit, time has passed since. So as I joined this company, as I joined this organization, this is roughly what I found. This was in one department within the organization. This organization has some 2,000 to 3,000 employees. And this particular department was and is responsible for the public digital initiatives. So digital initiatives, websites, apps that are used by the general public, not necessarily internally, even though they may be used internally as well. But this is the situation that I encountered. So what I found is a large monolithic application with a bunch of smaller services or monoliths surrounding it. And the monolith was connected to a bunch of database services, MySQL, Elastic, and some other stuff. And the monolith was connected to the internet and basically rendered HTML for browsers to use, but it also exposed an API that was used by mobile apps, iPhone and Android apps. Now, the key thing here is that the monolith was relatively well tested, and that's an important element during the rest of the talk. As I encountered the organization and the applications, the team structure in that organization was 4 teams, and we called them topic teams. Now, why the name topic teams? Well, you can imagine that this application serves a domain, right? The domain that this organization is in, or at least the department is in. So there's a couple of big areas that we call topics. One of those is you could buy a certain type of ticket. You could look up information. You could search for stuff, and so the domain of the application or of the department was essentially sliced in 4 pieces, roughly equally sized. And these pieces were split or assigned to 4 of those teams. And the teams were roughly identical in composition, of course, not in people. There's a few developers, there's a scrum master, there's a product owner, et cetera, et cetera. Pretty standard so far. Now, what happened is one of those teams would, from time to time, put on a special hat, and they would call themselves the fire team. And this role would rotate from team to team to team, right? So after 4 rotations, we would start back with team 1. So the fire team, as you might imagine from the name, this is a team that has the responsibility to fight fires, to deal with ad hoc situations that present themselves. So one of those ad hoc situations was a critical package or a dependency update, and deal with that. Also, the non-critical dependency updates, they can be planned, of course, but the fire team would be responsible for those. So package updates, we use all this open source stuff, and we want to be current. So if there is an update to one of the packages, to one of the dependencies that we use, we want to keep in sync. Why? Because if we delay that update, at some point, upgrading those dependencies will become very costly, right? So we try to follow the dependency as it updates. Maybe not the very latest version, but we want to keep quite close to that. So another responsibility of the fire team is what we call bug triage. And like people that have some experience with healthcare, for example, where triage is also a thing, bug triage is similar. A bug comes in, and we need to first classify the impact of the bug. Is it very serious? And how many customers are affected by this issue? Are we losing money over this issue? Or is this less of a problem? Right? So we divided the bugs in 3 priorities, 1, 2, and 3, where 1 would be stop and drop everything and work on this. 2 would be you need to work on it in a timely fashion, preferably within the next few days, but nothing's on fire. And then prio 3 would be something that, okay, we know this is a thing. It's probably an annoyance to some people. It would be cool if we can fix it, but if we need to wait a few weeks because we have other priorities, because we have other things, that's okay too. And the last and most important responsibility within the context of this talk is the release rollout. So the fire team was responsible for rolling out a release. I'm going to take you in a typical release. And to be quite honest, there was not a lot of typical stuff with each release, but we'll get into that. So let's go into what makes a release before we go into all the continuous delivery stuff and all the goodies. So as we encountered this organization, the release process was like this. There was a nice long checklist of many pages A4 when printed, lots of steps, all or mostly all manual, described in some detail what we needed to do in order to get a release out the door. And then let's take a look at the cadence of this organization. So there was a 2-weekly sprint, bi-weekly sprints, sprints lasting 2 weeks. And the sprint would start on the Monday and end on the Thursday of the next week. And what would happen is on the Thursday of the next week, so the end of the sprint, we would try to create a release candidate. The candidate, of course, because we're not really sure whether what we build is releasable, but we tried every 2 weeks to get a release candidate ready. So the candidate contains everything that we consider finished from the previous sprint or sprints, depending on whether we had a release the previous sprint or previous sprints even. And then we start testing the release, and hopefully by Tuesday, which is the release day, when we deploy the release, when we put it out there, we've done all the testing and all the fixes, all the rework. Okay, so bi-weekly sprint, and then hopefully it gets to our customer. Now, in an ideal scenario, we would have a release every 2 weeks. But this often did not happen because we were not ready with the release in general. There was not something releasable at that point. We had problems fixing the tests, all of those things. So in the optimal situation, we had a bi-weekly release cadence, but it turned out to be longer on average. Now, the release procedure, when you flatten it a little bit, when you reduce the checklist, it comes down to this. We branch for the release candidate. We deploy the release candidate to our acceptance environment. Then we signal the testers and the product owners involved. Go ahead and do your thing. Test, verify, validate. And then, of course, there will be fixes. We fix those on the branch and make sure that they get back to the main line, which didn't always happen, but that's another point entirely. And then once we've done the fixes, we get approval from the people, the POs involved. And then we deploy the thing to production, and then we verify that this actually worked, okay? So we did some calculation, and we found that this release cadence took 2 to 3 days of manual work for the entire feature team, for the entire fire team, I should say. So that's quite a substantial cost to do a release, okay? And this doesn't even include the hot fixes. Because, you can imagine we put a release out and we have a problem. We encounter something of a prior one nature, right? A serious impactful bug, a thing that we need to fix right now. And then what you would see is people were using an alternative release process. And they would start skipping some steps because they were under pressure. There was something broken, something was on fire, and it needed to be fixed right quick. And that's the interesting thing with a mostly manual release process, with a long release manual of this nature. Depending on the stress level, people start skipping stuff. Okay, and it's not enforced, and also it wasn't really trained, and that's the hot fix and the normal release procedure. That became sort of a problem. So all of these things, you may think about this, and you're like, you could be saying like, this is not really a bad situation to be in. Okay. And compared to some other companies I've consulted at, you would be very right. Okay. I've been at companies that release once or twice a year, and every release, every damn thing blows up. Okay. And this situation was a lot better. However, the competition, the market that this organization is in is fierce. Okay. Customers can choose within Europe where they do their business. And one of the only ways to differentiate is on the digital level, right? We build digital products in the hope that we attract customers so that they don't go to the next guy. Okay, so we needed to be able to innovate more rapidly, have less outages, more quality, have faster feedback on the things we were building. So we set a few goals. One of the important ones, and of course, I mean, this is not a surprise, is to reduce the cost associated with getting the releases out the door. And it's not reducing the cost like we can get rid of people, but we tabulated that 2 to 3 days of manual work for an entire team. How nice would it be if those people can spend those 2 to 3 days on other things, right? On more important things, on more useful things, rather than going through the motions of pushing a release out the door, which is ultimately repetitive work. So reducing cost, or actually spending that development time, that development euro on something more useful, that was one goal. Another one was fast feedback. We want to know quickly whether the thing we are building is A, working, and B, useful. So the A is working, is it technically working, right? Does it deploy? Does it start? Does it run? Do we have any bugs, et cetera, et cetera? And on the other hand, the thing that we built, is that the right thing for our customers? Is it something that they are interested in, that they are using? And we want to have fast feedback on both. We also wanted to get rid of toil. Now, toil, if you look it up on the internet, which means it's correct, you would see it's the kind of work that is tied to running a production service or application that tends to be manual, repetitive, automatable, tactical, and devoid of enduring value. Which basically, in summary, this is work that sucks. It's work that you don't want to do, and it's work that doesn't get any better. As a matter of fact, it's work that scales linearly as the service grows. So you're going to do more of it if you're not careful. And last but not least, we wanted to do more experimentation, A/B testing, and stuff like that, and ultimately put the PO, the business, back in the driver's seat. Right? I talked about how we would put releases out on Tuesday if we had a release. Now, that's a relatively random day, you would say, but it was pretty synced into the cadence and into the minds. And let's say you have a feature that you want to put live on Thursday and you don't want to have on Tuesday yet. Do you wait to the next heartbeat and you get all these merge issues? And so we wanted to have a better system for that. So then in comes continuous delivery. And let me explain why, okay? Continuous delivery is all about making things small. And making things small is good because if you don't do that, if you take big steps, well, the nice thing about big steps is that if they will fail, they will fail big as well, okay? So they will be costly. The failures. They will be problematic. They will be difficult to recover from. And also, if you take big steps and somewhere in that big step, a small piece failed, it's difficult to find out what happened exactly, right? If you have 1,000 commits in a release and one of the commits caused an issue, good luck finding that, right? Conversely, if you take small steps, then they might still fail, and then they will fail small, right? So it will cost less, it will be easier to recover from, it will be easier to change directions, and in general, that's a better way of doing things. So just as the doctor ordered, if it hurts, do it more often. And that's one of the things that we applied on this project as well. And what this basically means is that the only way that we're ever going to get better at doing stuff is doing the same thing over and over, failing a lot and learning and improving and making things small. And why is making things small so essential? Well, this graph illustrates the beauty of deploying functionality in small batches. Is you earn value faster and you reduce risks at the same time. Take a look at the left of the picture. You see an infrequent release schedule, right? There's not a lot of releases going on. And as we build stuff, we build up inventory, right? It's on a shelf somewhere. Nobody's using it. So it's not useful. It's inventory. It's like you see in a warehouse, right? Nobody's using the stuff that's on the shelves. And yet, in this case, we accumulate stuff. So we don't only build up inventory, we also build up risk. Risk is twofold in this case. It's a technical risk and a functional risk, right? The technical risk is that once we deploy, it may not work. It may crash, it may fail, it may not start, etc. And functionally, what we're building may be completely useless. It may be something that people are not interested in. So on the right side of the picture, you have a frequent release schedule, right? You go to production quite fast in small increments, and you still build up inventory, you still build up risk, but it is a lot less because you go to production all the time, right? And you can quickly verify and recover from failures and quickly change gears. And basically what we're saying here is that code that is not yet in production is potential waste. Luckily, I'm not the only one saying this. For example, if you go read the book Accelerate, if you haven't, I absolutely recommend it. Accelerate is basically the science behind continuous delivery in DevOps, right? And what they found is that if you look at high-performing teams, there are some significant statistics that are interesting to see, right? A high-performing team will have about 50 times more deployments in the same interval than a low-performing team. And they will have a lower change failure rate, so less of their changes will break or go wrong. And the interesting thing is they will be far faster to recover from something that they broke, okay? 100 times even. And so the science basically is there, right? It says that this stuff works. High-performing teams all do this. And it's in part what makes them high performing. Okay, back to the project. So we took an approach in this project that I'll first sketch and then I'll go into the individual phases of the approach. So the approach was split in 3 phases. We did some work after those phases, but for the sake of the talk and the interesting parts, it's 3 phases. And before we go into the phases, I want to talk about the monolith, because we did not split it, at least not initially. And, you know, a couple of years ago when microservices came around, everybody was like, oh, monoliths suck, and we need to split them right now and get into microservices. And anybody that builds a monolith is basically an amateur, et cetera, et cetera. So what we did is actually wait. So why? The monolith, as I said, was relatively well tested. We had a relatively good amount of confidence in how the thing worked. Okay. What we did not have confidence in was the amount of manual work. And the amount of manual work would have scaled up if we had split the monolith first, right? Then we would have a lot of pieces with a lot of manual steps. And we would have more manual steps. And that was not what we were intending to happen. So we waited with deferring with splitting the monolith until a later stage. What we did do in the first phase was increase our release tempo and add lots of automation and get rid of all those repetitive steps as much as we can. Second phase, we roll everything into a nice single pipeline that deploys something to production and validates everything automatically. And then we, in phase 3, took all the learnings from phase 1 and 2 and did a bunch of improvements to our pipeline and our testing. Okay, let's get into phase 1. Phase one, as I said, is about increasing the cadence of our releases, increasing the tempo of our releases. And what we said was, hello folks, this is going to cause some pain, but we're going to do this weekly, every week, no exceptions. And the pain that came out of that was exactly what we wanted to see, because if pain is visible, if pain is felt, people will be compelled to fix things, right? If something happens here with some person and another person feels that pain, then the first person is not really, does not really feel an incentive to fix things, right? Because they're not feeling the pain, they're not sharing the pain. So what we wanted to do is get some pain going and basically trigger everybody to start fixing things. And then what we started to fix things was all of these manual steps in the checklist, right? What we can automate, we automate. If it's super interesting and it requires, human thought, then maybe it's something else. But most of these processes don't require active human thought, right? They're repetitive steps, and we can robotize them quite quickly and easily in general, in most cases. Let's put it like that. So what we built was essentially an archetypical pipeline. What the pipeline does is it takes our code from GitHub, in this case, it starts building it, it puts out the package, a deployable unit, something that we can put on the server and have it run. And then we do a bunch of automated tests. We deploy the package that we built to an acceptance environment, and ultimately we deploy to production environment. Now, from the different colors, you see that there's already something going on. And what we initially did was put a big gate between acceptance and production. So once, the automated deploy to acceptance was completed, everything would stop. Because we were not ready to do automatic deployments, fully automatic deployments to production yet. So we added a button. And this was a virtual button, of course. It was something that you click with your mouse. Some companies I've seen have actual physical buttons that somebody pushes and gets a release going, which is also very cool. But in this case, it was a virtual button on a browser page somewhere. And so we built all these pipelines. And the nice thing, pipelines, just as much as infrastructure, just as much as regular code and tests, can be written as code as well, and should, to be perfectly honest, because then you can rebuild your pipelines from the code. You can see if you check them into version control, which you also should do. You can see who did what to the pipeline when, and maybe, if you break the pipeline, you can back out a change, you can revert something, and it saves you from clicking all the things in your Jenkins or what have you. So we ended up using Jenkins, and this is not really a pro Jenkins talk necessarily. It's just something we used and found useful at that time. If you ask me now, I might make another choice, but back then we used Jenkins and it worked very well for us. And we built two separate pipelines. The first pipeline deploys to acceptance and runs a few automated tests that we had at that point, not really of any great quality, but we had a few, and then it stops. And it actually waits for the button to be pressed, and then it triggers the second one, the pipeline that actually deploys the thing to production. So our deployment was, we started to automate that, but jumping from acceptance to production still required a human involvement, okay? And what we also did, of course, this is all technical, but that technical stuff, the tooling is doesn't stand a chance if you don't introduce a few changes in your way of working. And the biggest one we did was introducing pair programming. Now, pair programming, to me, is the way that anybody ought to program, because it has a demonstrable effect on quality, positive effect on quality. It is immediate code review rather than the async code review that you have with pull requests. You get knowledge transfer. You get design decisions that are shared by people And in general, it leads to better software, and that has been demonstrated all over. Pair programming, basically two people sitting behind a computer, one doing the typing, one doing the talking, or there are some other ways that people are doing it. But that's something that we introduced and encouraged. We did not enforce it, but we encouraged it a lot. And people quickly found that the quality of their software dramatically increased from the pair programming already. Another thing we introduced was the policy of don't leave broken windows in your code. What that basically means, if you see something in the code that is not according to the code style, or breaks something else, or doesn't, generally doesn't look nice, or at least doesn't look according to the agreements that you've put down as a team, then fix it, right? If it doesn't take too long, just fix it. Because from the Pragmatic Programmer book, I lifted this quote: neglect accelerates the rot faster than any other factor. And that's definitely the case, right? The broken window syndrome is an existing thing. It's not just a theory, it's practical reality, not only in software, but in general life as well. So we need to be careful with the code that we build, and not neglect it. So if we see something small, then fix it. And we also introduced, or rather got rid of, the release branches. Right? We push a build through our build server, and ultimately, if everything goes right and people click on the button, then it gets pushed into production. So we don't need a release branch anymore, right? If we need to do a fix, then we simply commit, get a new build going, stop the old one, and deploy the new one. And so a release branch is no longer necessary. So we started switching to trunk-based development, which, we used Git, so trunk doesn't really have a name, but trunk-based development, or mainline-based development, basically says we commit only to the main line of development, and only there, right? Because if you want to do continuous integration, you already have to go to the main line every day, otherwise you will violate continuous integration. So this is a simple step, right? And this is not new. Trunk-based development has been around for 20-ish years, I guess. And unfortunately, because of Git, branching became so much easier and cheaper that everybody started to use branches. So trunk-based development basically means only commit to your main branch, to master, or whatever it's called. And there really is no need for feature branches anymore, right? Feature branches optimize for the individual, and you don't want that. The main branch optimizes for the team. So a little bit of an asterisk there. We had some short-lived feature branches, and there was some discussion about that. What is short-lived? Is that hours or days? Well, we tried to keep it under a day. In some cases, within 48 hours, the thing needed to get rid of, but typically that was the end of it. And what we also did was add a bunch of hallway monitors, right? Ubiquitous displays, where we show metrics of all sorts of parts of the system, whether it's the back end or the front end or the database or what have you, in order to have us triggered by abnormal behavior, right? We would see a graph, and over time you would develop a sense like, okay, this is a normal value, this is normal behavior, this is the normal pattern, and all of a sudden you see a spike and it attracts your attention. And we also did some automatic alerting on top of it as well. And then once you're doing continuous delivery, or when you're implementing continuous delivery, when you're on your journey, it makes sense to measure that as well. Not just how your application is doing, but also how you are doing or how your teams are doing. Not to, talk with people about it or fire them or whatever, but measure how your continuous delivery trajectory, your journey is going. So again, we built a bunch of dashboards for that. For example, do we see a trend in the number of build failures that we need to address? Do we see other quality problems appearing? How What is the build duration? How often are we going to production? What's the average lead time, et cetera, and that all gives insight. This is not metrics that we would, enforce, but we would look at them as well. And then phase 2, we would go to the single pipeline. And phase 2 basically means that the 2 pipelines that we have, we now connect them together, and the human button press is reduced, or replaced rather, by a robotized system. So all the tests that we need to do in an acceptance environment are done automatically in order for us to build up enough confidence that we can deploy the thing to production automatically. And this is what we call continuous deployment. Okay? Continuous deployment basically says every commit, nearly every commit, and in at least every commit that passes the test goes to production. And that means something, right? I mean, that's a pretty upheaving thing for a lot of teams if it happens. And one of the things we found we needed when we sort of knew we needed was zero downtime deployments, right? If you do a lot of deployments per day, if that's where you will end up, then you will need to have some way of not causing downtime every time you deploy. And so we introduced the concept of the rolling deployments. We basically put a number of instances of our application behind a load balancer, and we used some automation for that, so that if you have a new version of the application, let's say version 1.1, what we would do is first start a new instance of the new version, and then once it's all booted, we replace one instance of the previous version with one instance of the new version. And we repeat that process until we have eventually replaced all of the instances of the old version with an instance of the new version. And if you do this right and you don't cause any backwards compatibility issues, nobody will have noticed that you just replaced your entire landscape with a new version. And that's a pretty cool thing. Okay? Now, there's also something unfortunate that I need to talk to you about, and that's pipeline failures. This might be one of the things that's not really in the books, right? Pipeline failures can be caused or can be due to a lot of things. One of them is the Flaky Test. Now, the Flaky Test is basically a test that you can't trust. Today it runs, tomorrow it fails. This build it works, the next build it fails, or vice versa. So it's a test you cannot trust. And a Flaky Test come in all sorts of shapes and sizes. For example, we have timeouts going on. You do async stuff in your browser, jQuery, whatever, and you have a bunch of timeouts. And then you restart your build, and all of a sudden it works. Network stability issues, right? You have your tests on one machine and your code on another machine, and the network between the two machines craps out, and all of a sudden you have a failing build, even though the code is fine. We found out the hard way, for example, that we had external dependencies in our tests. We would call actual APIs, third-party APIs in our tests, and then the third-party API would be gone for X minutes, and our builds would start failing. And mind you, this was usually the test API from some third party. So we wanted not to be dependent on that so much, because, if that breaks your build, you cannot do anything at that point. And we also have had some brittle infrastructure, machines dying, and our build server was not ready to deal with that. So all of a sudden a build would stop. And basically the message here is, if you have a test that you cannot trust, get rid of it, because it's going to cause problems, right? You're probably going to retry it, or at some point you're going to ignore the tests. And in all those cases, it's not adding any value. It's actually adding weight. It's adding a problem. So if you cannot trust it, remove it, rewrite it, whatever you do, but get rid of it. And if the pipeline does fail, stop the line immediately, because the pipeline is going to be your only way to deploy something to production, right? We want to get rid of all those manual things, of all those manual steps. So the pipeline is your way to production. So if it breaks, it needs to be treated as a bug of the highest category and needs to be fixed right away. And to know whether the pipeline has failed, you can employ all sorts of methods. What we call extreme feedback. I've used everything from sirens, flashing lights, noises, a USB-powered Nerf gun launcher. It doesn't really matter what it is, as long as it attracts attention, right? A simple Slack notification can do if everybody pays attention to that. Whatever is useful for you, make sure that you get people's attention to fix that build. And once it's all working, well, this is what it looked like in this particular situation. In this organization, we had a pipeline that ran from start to finish to between 20 and 30 minutes, from the pipeline starting when the code was checked in until everything on production was deployed, okay? And in between, we did all sorts of stuff. Unit testing, integration testing, acceptance testing, deploying to acceptance, pushing our artifact somewhere, deploying to production, all those things. And we would be done in slightly under 30 minutes. Pretty cool. Now, in the goals, a little bit ago, I talked about putting the PO back in the driver's seat. So this is all about timing the release of features, right? And timing the release of features used to be done by putting our feature on a feature branch, and then once it's ready and once it can go out there, merge the branch and then quickly deploy it. But there's a far less invasive way, and that's called the feature toggle. And the nice thing about the feature toggle, it allows you to decouple the deployment from the release. The deployment is a technical exercise, right? We deploy code to an environment, to servers or a cluster, whatever, and the code may or may not be active. But putting the code on a machine, on an environment, that's a technical exercise. Whereas releasing something is a business exercise, right? It's making functionality available to your end user. So if we can pull the two things apart, that would give us a lot of flexibility, right? We can build stuff and have it enabled for certain customers or not yet, right? We can switch stuff on and off without going through all the hell of merges on a code level. And so we ended up building a dashboard where we could, flip features off and on, and even have an individual override for a tester, for example, so they could see the feature active in production, but the rest of the world wouldn't see it yet. Okay, and then the PO, once they were ready, they could simply flip the switch, and that's all that it was. And so what this allows you to do is have features that take quite a long while to build, and you can keep deploying things, even though the feature is not ready for prime time yet. So that's pretty cool, because if you were to wait for the feature to be ready, you would halt all your deployments or build up this huge feature branch, merge it at some point. We all know how that goes. So this is definitely a better way of doing things. One little caution there, though, feature toggle debt is a real thing. So don't just randomly add feature toggles to everything. Not all functionality actually needs a feature toggle. But if you do end up adding one, then plan something in your schedule, in your planning, to get rid of the feature toggle after a few weeks of runtime in production, right? By that point, you know whether the feature is actually any good. So if it's not, you yank out the feature and the toggle. And if it's good, you simply get rid of the toggle. And that keeps the number of feature toggles to a manageable level. Last phase, doing a bunch of improvements to our pipelines, to our testing, and to our system in general. So one of the things that we were talking about was making our pipeline faster. And this in itself it's not a goal in itself, right? Making the pipeline faster, but it gives you faster feedback. And that's a pretty cool thing, right? You build something, and within 5 minutes or something, you know whether the thing that you built is probably going to survive a production deployment. And that's very nice. It allows you to be very fast and have extremely small steps. So what we did initially was, scale vertically, scale horizontally, buy a bigger box and buy more boxes. But we also did some parallelization, right? You can do a bunch of tests together at the same time, as long as you have enough horsepower on your build server, of course, and do some preparation stuff before you deploy, et cetera, et cetera. And we got our pipeline speed down to quite a nice number. And what we also did was improve our level of testing. And of course, that simply means more automated tests or automated tests in general, because a lot of organizations suffer from this thing. This is what they call the ice cream cone of testing. And what you see in this ice cream cone is basically not a lot of unit tests and a shit metric ton of manual testing. And that's what a lot of companies have, unfortunately. The better way would be to turn the ice cream cone around, and then you would have the testing pyramid. And the testing pyramid basically says that if you have unit tests, they're going to be fast and cheap, right? So you want to have a lot of them. And as you go up in the testing pyramid, your tests are going to be more expensive, more costly, more brittle, difficult to maintain. And so you want to have less of them, right? That's your N2S, your UI tests, your acceptance tests. You want to have as few as you can get away with. Whereas on the unit testing level, go ahead and do it, as long as your unit tests are fast, of course, right? And that's when you get into the quality engineering mindset rather than the quality assurance, because you cannot assure quality. You can engineer quality, but quality is in a product or not in a product by the time you inspect it, right? You cannot inspect quality into a product. You can only build it in. So quality engineering is a key component here. And it basically means your testers are not going to do manual test scripts. No, they're going to be involved at the beginning, writing automated tests and making sure that that quality engineering mindset is there. A big part of the testing we did was contract testing. Contract testing is a relatively new field where we test the contract between, for example, an API producer and an API consumer. And contract test tools like Pact and Dread allow you to verify that the exchange between the consumer and the producer did not break. Right? Backwards compatibility breakages are a big problem in API design and API development, and you want to guard against that. Contract testing helps. UI testing, of course, we all know Selenium, but we invested in a tool called Cypress, which is an open source tool, which is pretty popular these days. And it's basically a more lightweight and less brittle, more stable version of Selenium. It attaches directly into your browser, and it has a nice, rich language to verify that your UI is doing what it needs to be doing. And we also experimented a bit with visual regression testing. Elements jumping off page because of a CSS error are difficult to detect automatically. And we experimented with some tools such as Applitools to verify whether they would actually be useful. And last but not least, we introduced dependency scanning, right? These days you have a lot of those. You have Nexus, you have Dependabot, all of these, Renovate, and more of these tools that basically scan your open source dependencies. Are there any vulnerabilities? Is there a version that fixes the vulnerability? What version is it? Do you need to pull in other dependencies, et cetera, et cetera? And that gives you insight on the many dependencies that you use, right? Typical applications use lots of dependencies, and you want to be in control there. All right, closing off with a bunch of results and takeaways. And let's first start with some of the learnings. So as I described during the session, pipeline speed and stability are key, okay? Pipeline speed because you want to have quick feedback, stability because you want to have something that you can trust, and because the pipeline is the thing that you use to deploy to production. So again, if the pipeline fails, deal with it quite quickly. And also make sure that you test your pipeline. That's what we ultimately ended up doing. But at first, we simply wrote the code and ran it. And then the pipeline could break. And it was difficult to detect in some cases. So sounds a bit like the movie Inception, but test your pipeline that tests your code. And way of working changes, mindset changes need continuous attention, right? You don't just tell everybody like, okay, now we go ahead and do pair programming and everybody starts pair programming and do it perfectly. No, that requires a lot of attention, a lot of coaching, a lot of helping. And that requires effort, essentially. So keep that in mind. We found that visual testing tools were not to the point that we could use them in the pipeline automatically. So we used them once a day or something to verify, but the number of false negatives was too great for us to include it in the pipeline, and it would become just another flaky test, basically. Cool. Now for some cool numbers. 4,000 tests on average per deployment. This is the entire mix, right? Unit tests up to end-to-end tests and everything in between. Doing all those things and deploying the stuff, roughly 10 minutes per pipeline run on average. Which translate to a lead time of 1.5 hours from development to production. I start typing away on my keyboard, at some point I commit, and it gets pushed, and on average 1.5 hours from the development to the production, which is a nice number, right? That's pretty fast. In 6 months, we calculated that we did more than 5,000 deployments, which translates roughly to 30 to 40 deployments per day. On the days that we were active, which is a pretty cool number. It's not a number that you necessarily need to chase. It's not a goal in itself, but it's indicative of the level that we reached and the ease that we achieved with doing deployments. So thank you for listening. Once again, you can reach out to me later if you think of a question after this session, tomorrow, whatever. Reach out on my email, on my Twitter handle, and go to my website where I talk about this topic and a lot of other stuff. And let's take a look at the chat because I saw 1 or 2 questions pop in as I was talking. Ludo asks, how do you do pair programming in the COVID area? Well, for those of you that use IntelliJ or one of its derivatives like PyCharm or PHP Storm or whatever, there's the Code With Me plugin, which is pretty cool. It basically turns the keyboard of your colleague into your keyboard, and you can, work together. You can even add a video, and you can do all these things. So it basically turns both of your computers into one shared remote working experience. I've done, simple calls. We put a Skype call or a Zoom call or whatever. We both have the screen. And then what we would say is, okay, the person doing the typing, which is the driver, we call that the driver, they would share their screen and the navigator would tell stuff that needs to be typed. And at some point you would switch roles. And basically you would then do a commit and then you would switch roles, right? The other person would share their screen and you would continue from there. So that's how you do pair programming remotely, and that works pretty cool. That works just as well as live. It might even work better to some degree. The other question that I saw, what do you do in case of a hotfix needed in production ASAP? Well, that's a good one, Sander. So this is on average. The pipeline is on average was 10 minutes. So in some cases you would have, like a backlog of commits that would come in. We would typically on the next build take all the commits that were waiting, right? We would not do a build per commit. So if there's a build running and the build finishes, then it picks up all the commits that are waiting that were not part of the previous build. So in all reality, you would probably not have to wait very long. But if the current build that is running is still in the testing phase, it's not deploying things yet, and there's absolutely blind panic, you can stop the build. But we've never had a need for that. 10 minutes is faster than most people can fix a high priority issue. And if you have a high priority issue and you want to have the pipeline available and free for your fix, then shout to everybody, the pipeline is now blocked because of this high priority thing. Okay? That's how I would do it anyway. And I see WebStorm has the Code With Me extension as well. And there's something for VS Code as well, which I don't use, but that's cool, Raphael. Thanks for sharing that. Are there any more questions? Looking at the chat, I don't see anyone. Yeah, Jordi, the Nerf gun, unfortunately, I think it's not for sale anymore.
Ah, that's a shame.
Yeah, afraid so.
Yeah, definitely. I might have to get an alarm or something, then a siren or something that goes off. Just make sure it
Yeah,
doesn't wake
we
up my
did
neighbors.
some, in a previous project, we did something like that as well. And we used, the sound a train makes when it's going into a tunnel or something, or a foghorn or stuff like that. That tends to get people's attention as well.
Yeah, you might have some hearing damage, but you'll know that something's up.
Exactly, yeah. Yeah.
Yeah, no, a while ago we did have a deploy button for one of our projects, and it was just a big red button with fire lasers on it, and it would do
Cool.
everything you wanted it to do. It was really cool.
Cool.
Yeah, thank you very much for your talk. I won't
More
keep
than
you,
welcome.
keep you here for too much longer. And yeah, we'll have a small break, I think 5 to 10 minutes or so, and then we'll have the second talk from Louise.
Cool.
Thanks again, and maybe talk to you later.
All right. Thanks for tuning in, everybody.
Bye bye.